This video is on grade 7, module 3, lesson 10, example 4, which can be found on page 63. Let me slide on over. There we go, 63. All right, so getting into this one. This one's kind of fun. So it brings back some old topics. So we got the following two lines intersect. Intersect just means they cross. The ratio of the measurements of the obtuse angle to the acute angle in any adjacent angle pair is in this figure is 2 to 1. Then they're asking us to describe the angle relationship in this diagram. So some words to remember here. Ratio is the first word to remember, and they give us the ratio right here. Remember, ratio means it involves multiplication. So for every single amount for this one, the other amount is twice as much, 2 times as much. So what are the amounts they're talking about in this case with the ratio? Well, they say the measurements of the obtuse angle. So measurements of the obtuse angle, that's the thing that's going to be twice as much as the acute angle. And we remember what obtuse and acute is from the types of angles chart we filled out at the beginning of this lesson. So let's actually look at the angles in here. So the obtuse angle, remember, obtuse means any angle greater than 90 degrees. So the obtuse angles in this one are going to be, let's say, this purple one right there. Try to make it a little more solid. So this angle will be obtuse. Also, this angle is obtuse. And you could say that's because they are vertical angles. So if this is obtuse, well, vertical angles have the same measure. So this would be obtuse. You could also use the idea that they're angles along a line. Whereas if this one's obtuse, then this one here and here, this angle must be acute. We'll actually throw the words in there. So this would be acute. This would be obtuse. Obtuse. And which leaves us this one from here to here would be acute. All right, so let's actually talk about this ratio they give us. They give us the ratio of 2 to 1. Now, that means for every measurement of the acute angle, which is the 1, the obtuse angle is twice as much. But we don't know what the acute angle is. So here's what I'm going to do. I'm going to put in x degrees for the acute angle because I don't know what the actual measurement of the acute angle is. So x degrees. That means over here this is x degrees. And remember, there's an invisible 1 in front of that x. And the ratio 2 to 1 tells us, okay, 1x is the measure of the acute angle. So the obtuse angle must be 2x degrees based on the ratio they give us. Okay, so we kind of labeled up our diagram with our lines and our angles. Now we're going to actually get into describing the angle relationship. So let's do this. I'm going to put this in yellow. And there are several different ways you can go about this, but we're going to do this. Let's talk about this line right here. So this line is a straight line. It tells us there's two lines that intersect. And I'm going to remind you that every line has an angle, a straight angle, that equals 180 degrees. So from here, from facing this direction to rotating all the way around requires 180 degrees of rotation. So we can say this. We can say the measurement of the obtuse angle is twice the measurement of the acute angle. Again, that's from the ratio that they gave us, this 2-to-1 ratio. That's the reason I can say it's twice. Also, we can say the measurements of one of each obtuse and acute angles have a sum of 180 degrees. So keep in mind, we're talking about one of each, so one of the obtuse, which is 2x, and one of the acute. The sum of those, which means added together, equals 180 degrees. So let's go on to the next step, the next set of directions, which we kind of did already. It says label the diagram with the expressions that describe this relationship. Write an equation that models the angle relationship and solve for x. So we already labeled it by labeling it acute and 1x, obtuse and 2x, and then showing how this straight line has an angle measure of 180 degrees. That's the first part they told us, is labeling. Let's write an equation now. So the equation is going to come from this second sentence we wrote in the part above. So the measurements of each obtuse and acute angles or one of each of obtuse and acute angles have a sum of 180 degrees. Well, again, the word sum, as we did in a previous example, sum means equals 180 degrees. And the two things we're adding to get that are the obtuse angles. The obtuse angle is measured as 2x degrees, and the acute angle is measured as 1x degrees. Okay, so write an equation that models. We just wrote an equation, and then we have to solve for x. So let's go ahead and we'll solve in for x. So 2x plus 1x equals 3x degrees equals 180. There we go. Now we're just going to get x all by itself by dividing each side by 3. So x degrees will equal 60 degrees. X equals 60. So there we go. We solve for x, but keep in mind they're asking us to do a little more. It says find the measurements of the acute and the obtuse angles. So let's do the acute first. Over here, we saw, here, let me just draw a little line to organize this. The acute angle was equal to x degrees. So the acute angle equals 60 degrees, because x equals 60, the acute is just whatever x equals. So there we go. Step one is done. Well, step one of our last final step is done. We got the acute angle is 60 degrees. Easy enough. The obtuse angle just takes one more step of work, because remember, the obtuse angle equaled 2x degrees. So the obtuse angle equaled 2 times 60. So finally, the obtuse angle equals 120 degrees.